26. Ask you determine the amount of heat in kilojoule given off when 1.26 times 10 to the fourth power gram of NO2 are produced according to this equation. This equation is 2NO react with O2 produce 2NO2. Heat released, also the reaction enthalpy of this reaction is negative 114.6 kilojoule. More. Now ask you how much heat given off when 1.26 times 10 to the fourth power gram of NO2 produced. NO2 produced 1.26 times 10 to the fourth power gram produced. How much heat released based on this balanced thermochemical equation. So this thermochemical equation is when 2 more NO react with 1 more O2, the number is 1, produce 2 more NO2, will release this amount of heat. Now if 1.26 times 10 to the fourth power gram of NO2 produced, how much heat released? This heat will be different with this, right? So this number is based on this balanced equations for 2 more NO2 produced. Now, this amount. The first thing we need to convert this into more. Then we can use this, right? Because this is based on 2 more NO2 produced. Release this amount of heat. Then this is the mass. So we need to convert this into more. Then can use this relation. Right? How can we convert mass into more? Do you remember? I also write here, right? So mass divided by molar mass. Molar mass, m(2 more). If we know more, back to mass will be more multiplied by molar mass. Another half is here, the number of particles, right? So mass divided by molar mass. What is a molar mass? You need to use periodic table. Periodic table tells us N is 14. O is 16, but you have 2 O there. Periodic table tells us O is 15.9994. Okay, just 16. So you have 2 O there. So together, 32, 14, 46. Okay, so this is mass divided by molar mass, you get more. Then you need to use this equation. For every 2 more NO2, every 2 more NO2, up to here is how many more than NO2, right?
One more. One more would go on top of that, though, wouldn't it? Maybe 1 mole divided by the 2 moles.
Here is moles NO2, right? Mass divided by molar mass becomes more, right? This is mass cancelled, left over more. Now is every 2 more NO2 produces this amount of heat, not 1 more NO2 here. Because finally we need to figure out how many kilojoules heat released. Right? That's why more in bottom, because here you already have more NO2, so more can answer the leftover kilojoule. Can you get it? Okay. Then use a calculator. Easy. So this is mass divided by molar mass times this divided by this 2. Why divided by 2? Do you understand this? Because this balance the equation tell you. This balance the equation tell you every 2 more NO2 produce this amount of heat. Use calculator, we can easily get this number will be negative 1.57 times 10 to the 4th power. Unit is kilojoule. Are you okay with this? Now take a look. Next question. Let's see. Which one I plan? Next is 35. Actually, 35. Also, you calculate the amount of heat liberated from 366 grams of mercury when it cools from 77 degrees Celsius to 12 degrees Celsius. $367 grams mercury cools from 77 degrees Celsius to 12. Ask you how many kilojoules of heat will be given off. What formula are you going to use? So this is just the cooling or heating, no chemical reaction happen, right? Hot matter cools down. The formula is this: Q equals to. You remember what is the formula? M is a mass times specific heat of this material. So we need to use a table. Then delta T is temperature change, right? During the quiz, I will provide you a table. So you need to use a table to find out the specific heat. Like for mercury here, if this is R, then you need to find the R's, Fe, what is specific heat. So M is a mass here, 366 grams. Specific heat of the mercury, as I said, you need to use a table. So during the test or quiz, I will provide you this table. So mercury is 1.139. Unit is joule per gram per Celsius degree. The specific heat, the meaning is how much heat needed in joule. For 1 gram of this substance, temperature change is 1 degree Celsius. So temperature change is 1 degree Celsius. Then actual temperature change is this difference, right? So any change always a final minus initial. So 12 is final. 77 is the initial. Unit is Celsius degree. So Celsius degree consider this per Celsius degree. Gram consider this per gram. Leftover joule. So use your calculator. You can easily get this will be negative 3306.8 joule. Are you okay with this? Then take a look, 57. 57. We need to use this half. From the standard entropy of formation, I will provide you a table. Okay. Standard entropy formation, the table will looks like this. Okay. Table looks like this. Substance listed here. The standard entropy formation, next column. And the substance formula, the standard entropy formation. Okay. The specific heat, we have another table. Yeah, it looks like this. Like the previous example is mercury, Hg, mercury, 0.139. You're going to use these tables to finish your quiz. Okay, the 57. Question 57. From standard entropy formation, calculate the reaction entropy change. The reaction is C6H12, which is a liquid, react with oxygen gas, produce carbon dioxide and water. So as you use standard entropy formation, the value comes from the table. Calculate this reactions entropy change. The reactions entropy change we label as this reaction standard entropy of this reaction. Remember the formula? Reactions entropy change is total standard entropy from products. These two are products, right? So 6 more carbon dioxide. This is the first product, right? Second product, 6 more liquid water. So these two are products. Be careful, this water is liquid. You need to label it because this table 6.4 will list two different type of water. One's liquid, one's gas. They have different value. Okay. So when you take a look at the table, be careful. This is liquid water. Don't use the value from gas water. Okay. Then minus reactant C6H12. Another reactant, oxygen. 9 more oxygen. Right. So this is total standard entropy formation from products. These two products. Minus total standard entropy formation for reactants. These two. Right. If this is your work, problem solving, you need your work. This is the first step. Then plug in the number. Take a look at the table I provide. What is the standard entropy formation from carbon dioxide? Take a look at the table I provide. So this is negative 393.5. Again, this liquid water. The table lists the gas water, liquid water. You need to take a look carefully. Plug into the value for liquid water is negative 285.8. These two product. Then reactant C6H2O. The value is negative 151.9. Oxygen gas. Of course, you can take a look at the table. For me, I even don't need to take a look at the table. This free element, right? 0. Okay. Free element in the most stable form, that's 0. So O2 is the most stable form. If O3, no. That's the second step. The rest just give answer. You don't need to show me this time this is equal to what, this time this equal to what. You don't have to show me. You can, but this is not required because this is pure math. And just give answer. Negative 39.2349. Unit is kilojoule because all these numbers units are kilojoules. So minimal 3 steps. First is formula. Total standard entropy formation from products minus total standard entropy formation from reactants. This is the first step. You can don't skip this. If you skip this, you'll lose the point. Because the rest is based on this formula. So from this formula, take a look at the table. So each value of standard entropy formation. Then give answer. I can tell you the last step is the least important. If this is 5 points problem solving, this two, the last one maybe only 1. If in the test there's 10 points problem solving, maybe this 4.5, 4.5, and this only still 1. And so last step, final answer is least important. To work is most important. Of course, in test or multiple choice, right? We don't have should work. The reason I explained why quiz needs should work, I want to see if you really understand, not just find answer. If you didn't understand the method, you most probably you cannot get final answer. Are you okay with this? Okay. Then next one is 63. Okay. 63, we have a similar in the class video. I don't know. I wish everybody watches the class video 63. This is Friday before spring break. Did you watch this class video? No? You need to watch it. We don't have time to go back. Right? Watch it today after class. Either evening time, anyway, whenever you get a time. We'll not repeat that part, but this is a similar example as an example shown in the class video. It's different example, but similar. Okay, so now listen carefully for this one. This one, ask you from the following heat of combustion, calculate the enthalpy formation of methanol from this element. So list the 3 reactions enthalpy change. The reaction 1 is CH3OH, which is methanol. React with 3/2 oxygen gas, use carbon dioxide and water, liquid water. Let's label this as delta H1 because this is reaction 1. So make you either reaction 1, this delta H1. The value is negative 726.4. Unit is kilojoule per mole. Reaction 2, carbon is graphite. Carbon will have two allotropies. Most popular is graphite. Another is, anybody remember? Carbon as a free element will have two allotropies, not isotopy. Isotopy is carbon 12, carbon 13, different mass number because of different neutron in the same nucleus. And here we talk about allotropy. The different type of substance or state. Carbon, most popular is graphite, like a pure core is graphite. And now is a diamond. If you never take a chemistry class, you cannot believe diamond chemically is just copper. Because of structure different, diamond is very expensive. This is very cheap. Nobody use diamonds in chemical reaction. in some research lab could use it because we want to study the reactivity. Right? So graphite react with oxygen gas produce carbon dioxide. This entropy change, since this is reaction 2, we label it delta H2. This is negative 393.5. So then, since this is a synthesized carbon dioxide from its element, right? So this actually is the standard entropy formation for carbon dioxide. You see here, carbon dioxide, this value is 393.5, right? Negative 393.5. Reaction 3 is hydrogen gas react with oxygen gas produce water, liquid water. So this is synthesized liquid water from its element. So this reaction entropy change actually is standard entropy formation for liquid water. Liquid water product, second product, right? Negative 285.8. So these three reaction entropy is non-value. Ask you calculate reaction force, standard entropy formation. Actually, reaction force, standard entropy of reaction. Because the question asked here is calculate the standard entropy formation for methanol. Standard entropy of formation of ethanol. That means this reaction is synthesize this compound from its element. Element, you have carbon, you have oxygen, hydrogen, right? So this equation actually is carbon, of course, graphite will not be diamond. Hydrogen, we need more space, sorry. Need more space. Hydrogen gas, oxygen gas, produce methanol. The equation here actually gives you so 2 hydrogen, 2 times 2 is 4, 3, 1, 4, right? 1 oxygen, so this is 1 half of 2. So this reaction is synthesize this compound from its element, carbon, hydrogen, oxygen. So this reaction 4 is a standard entropy formation of this compound, methanol. You get it? Explain, just get explained. Why I label delta H4 is delta H5 of methanol? Because this reaction 4 is synthesize this methanol from its element, right? This is the definition of standard entropy formation. F is formation, right? So overall, this question is, how can we calculate the delta H4, which is delta HF of methanol, from these three related reactions? The idea is, how can we build up or assemble equation 4 from equation 1, 2, 3? Okay. The idea is, equation 4 from equation 1, 2, and 3. This is a critical idea. How can we build up equation 4 from equation 1, 2, 3? You simply just take a look at what do we need for equation 4. We need a carbon. We need a carbon. Then take a look at these three equations. Which one have carbon? Clearly equation 2, right? So equation 2 provide a carbon. It's provide a carbon. So we get this. And we need 2 hydrogen gas. Then which equation give you 2 hydrogen gas? Yeah, equation 3 provide you 1. Then we can multiply by 2. The number or quantity we can multiply a number, right? So equation 3 provide hydrogen, but only 1. So we multiply 2 of equation 3. So plus 2 equation 3, then we get hydrogen. Next, we need oxygen. Oxygen not so easy because all three equations have oxygen there. Then how many each of them needed? You don't know. It's not very easy. So we just put aside. Okay. So this is undecided. Now we need CH3OH. CH3OH, clearly only equation 1 has. But equation 1, CH3OH is a right hand, is the left side. For this equation 4, we need it serve as a product in the right side. That means we need to switch right hand with product. Then just minus equation 1. Minus equation 1, that's negative. Both right side is positive, right? So one way is just minus equation 1. Another way, you can rewrite the equation 1 becomes equation 1 prime. Switch your right hand with the product, then change the value. Negative becomes positive. Same, you minus this, minus negative is positive, right? The same idea. So we need definitely minus equation 1, then we can provide CH3OH as a product. Left over one problem here, we didn't solve oxygen because all three reactions have oxygen there. I can assure you, if you run this, oxygen already there because every one have oxygen. But you may still have a question if this really give you equation 4, right? You may still have this question. If you're not sure, if you still have this question, if this really give equation 4, then you can work in the scratch paper on how to show me. You just work on your scratch paper. Confirm this give you equation 4. Now I show you we can get this equation 4. So use this formula. Equation 2, let's work on the left side first. Okay. Equation 2, left side is C plus O2, right? Hey, listen carefully. If you miss this, No other example before quiz. I can tell you this similar will be in the quiz. If you didn't listen, if you didn't understand this, you're going to miss. Again, equation 2. Work on left side first. Okay, all this equation left side first. So left side equation 2, C and O2. Okay, there. The equation 3 times 2. Again, left side first. Equation 3 times 2. 2 times 2, right? Two hydrogen, then 1 oxygen, right? 2 hydrogen, 1 oxygen. Minus equation 1. So minus CH3OH minus 3 half oxygen. We finish this formula left side because all these are left side, right? Now work on the right side. Right side still use this formula. Equation 2, right side, CO2. Equation 3 times 2, right side. Equation 3 times 2, right side is 2 water. Then minus equation 1, right side. This time is all right side, right? Minus CO2 minus 2 water. Minus CO2 minus 2 water. We finish this equation, this formula, right? So we will see if this result is equation 4, because you have a question. We want to confirm. If this equals to equation 4, so we need to simplify it. Carbon dioxide minus carbon dioxide, right? 2 water. Right side, nothing left. Left side, carbon, nothing to combine, right? So only 1 time. We get it. Hydrogen, also nothing to combine. 2 hydrogen. Then oxygen, you find we have oxygen there. 1 oxygen plus 1 is 2. 2 minus 3 half. Left over 1 half oxygen. Right? This only 1, nothing to combine. Minus CH3OH. Right side, nothing left. For chemical equation, normally no minus because chemical reaction is A reacted with B. Reacted with B is A plus B, right? So negative move to the right side becomes positive. Then we just is this the equation 4? This is the equation we want. So now we confirm equation 2 plus 2 equation 3 minus equation 1 give us equation 4. We confirmed again. This process is you work in your scratch paper to confirm this formula give you equation 4. You don't have to show me. If you want to show me, you need to work correctly. Otherwise, you lose one. Right? But this you do need to show me. This is the first step, most important step. Without this, if you only give answer, quiz no. You have some. If you give correct final answer, you can make it very small part point. This is the most important. Then from this, that means delta H4, because we want this, right? Delta H4 from delta H1 from equation 2 is delta H2 is delta H2, right? So delta H2. Equation 3, delta H3. But you need a times 2, because 2 times equation 3. 2 times delta H3. Equation 1, delta H1 minus delta H1 to give us equation 4. This is equation 4's enthalpy change. And the equation 4's enthalpy change is CH3OH is a standard enthalpy formation. So this explained just follow the same rule from this formula. Replace the equation by the delta H. The second step, you must show from here to here. The rest just plug into number. Okay. Delta H2, negative 393.5. Delta H3, negative 285.8. Delta H1, negative, be careful, this is minus negative 726.4. This is a standard enthalpy formation of CH3OH. This is third step. Then just give answer. From here, use your calculator. You can easily get final answer will be this plus this minus this. Final answer will be 238.7, negative 238.7. Unit is kilojoule per mole. Yeah, I hope this is recorded. Do you have any other question?